it streaming. And 10 seconds. Why is it not gotten ready?
I'll try. I have shit handwriting on this.
Dylan!
Sorry. Bad handwriting.
That one. It's inspirational and Fortnite. My original one was I saw it on Pitbull said I conquered it.
Taylor! That's not chemistry.
But I got it.
Taylor! Chit!
We're supposed to like write what it goes to.
We got that one. Do I want another one? Excellent. Yeah, that'll work. Ashwin?
Yeah?
I can hear you from here.
Oh, my bad.
That's not even chemistry.
My bad.
What?
What's your regatta job?
And what's your regatta job?
Yeah.
Why are you trying to distract me? Stop that.
No, are you excited?
Oh wait, I have an actual question.
No, you don't.
It's about the regatta job, but it's like an actual question.
If I let you ask the question, am I going to regret it?
No.
That's what?
Okay. I'm on house security. What do I do? Do I just
I
sit there?
immediately regret this question. What day do we meet?
19. I don't know.
Thursday.
We've had 2 house meetings. And you've been emailed.
I wasn't here.
I'm going to stab you with the bluntest instrument I have.
Monday.
Pardon?
I wasn't here on Sunday or Monday, so I missed both house meetings.
You were also emailed.
No.
And it happened last year.
No, but I didn't have it.
There's no assembly this week. So you go to your regatta job, boss.
Who is that?
It's your husband.
I know. Where?
In Privet, upstairs common room.
Oh, okay.
I did it last year.
You've been sent a sheet, and it says who your boss is and where to go. It will be in the house.
Wait, did you get the email this month?
Eshwan,
Yeah.
please predict the products of this one for me, please. I said please twice.
SR SO4. Double squad.
No, it's H2O plus something.
Tell him, not me.
That can't be right.
Why can't that be right?
Because it's weird.
Okay.
Right.
Is it right?
Yeah.
I
Oh, it
don't
is
know.
right. It is right. What? React the other. Oh, so. Oh, H2O.
Nice.
Oh!
Well done.
What happens to the other H? There's 2 H and it just leaves.
But there wasn't 2
It's
OHs.
2H. No, because it's open.
We have to balance it, so you have to put 2 O's.
So how would you balance it?
2H.
2 in front of the water.
So balancing, remember, you don't keep the things. You balance it afterwards. Strontium is +2. Sulfate is -2. Your table of polyatomic ions, if you don't recall them well, will be very handy for you in this section. Charges really matter. And you need to balance afterwards. Now for the next one.
Oh,
Really hurt.
Nope, not answering your questions anymore.
no.
No, you lost it. No,
I'll
no.
tell you the answer for the second one.
Oh!
Okay.
He's intrigued.
Okay. CaNOV plus 2H2O. Right? Or no?
Almost.
Almost.
You gotta balance it.
Yes?
But yeah, no, there should be 2 of them, and then there should be 2 in front of the H one.
Oh.
Here we go. So NO3 is -1, so we have to cancel that. Calcium is +2.
Oh.
Now, this is a what kind of acid?
It's probably strong.
Strong acid. What kind of base is this?
Pretty strong.
Strong base. What kind of base is this?
Strong.
Strong base. What kind of acid it is?
Strong.
Kind of.
Medium strong.
Strong, weak.
H2SO4 goes to H plus HSO4 minus. What kind of thing is that?
Strong.
A weak
It's a weak
acid.
acid. So its product is going to be a weak base. So when we look at our products and we say, is our solution going to be acidic, basic, or neutral? In grade 10, you'd say neutral because they annihilated each other. Water's always neutral, so we don't care about that. This is a strong acid and strong base. Calcium is not going to do anything in the water, and nitrate isn't going to do anything in the water. But strontium sulfate will absolutely do something in the water. Strontium sulfate. So we are bringing back dissociation equations. From solubility. What is the dissociation equation for strontium sulfate? No, I don't. Put up your hand if you know. Or take a guess. You want to take a guess? Hand, so I know who to pick up yours first.
SR -2 aqueous.
Where is this in the thing?
It's gonna be positive.
And then, oh no, that's positive.
Perfect.
And then sulfate would be a -2.
And sulfate would be a -2.
Aqueous.
And they're aqueous. And so this is going to make an aqueous product. This is, if this is a whole thing aqueous, it's going to dissociate completely one-way arrow and make these two things. So we just get ions in solution. Of these two ions, which one will react with water?
SR.
Well, one of the ways to think about is which one is the conjugate of something weak. So strontium, we last saw as part of a strong base. So it can't go backwards, so strontium's not going to do anything. So all of our +1 and +2 metals do nothing. But sulfate is the product
Hydrogen sulfate.
of hydrogen sulfate. So both of those are weak, so this can do something, and that leads to the next part of the section, which is what it's named after, which is the hydrolysis reaction. So the first part is picking which one is going to undergo hydrolysis. And in this case, it's going to be SO4 minus 2. And given all the acid-base stuff that we've been doing, if I react that with water, what kind of arrow? Double. And then Dylan, what would the products be?
I'm trying to write. Oh, it's HSO4 and OH minus.
Nice. Well done. I like the squeal.
Hydrolysis.
So it is
Hydrolysis?
hydro
Water cutting. Water cutting.
water cutting. And we cut the water in half.
Bro, it's like from a
It lysis from bio, cut in half. So hydrolysis. Weirdly, a hydrolysis reaction can be two different things. This is a hydrolysis equation. You can also split things with water. We'll see it in other places, but this is what it means in this context. So there's two types of reactions in this section. One, dissociation equations to separate out the things. And then second, the hydrolysis, once you figure out which things are going to react with water. Now, a lot of them are going to be bases. You have to react them with water. You can have hydrolysis reactions with acids. So this is still a hydrolysis equation. It's also an acid equation. And what would its product be?
H2. Wait, no.
H2FOH minus.
No, it's.
Remember, acid H plus is really H3O plus. H plus is just like the disguised version of it. But this is what really happens in acids. This is technically also a hydrolysis. If we happen to have HF around it, we'll do this. When we're looking at the products of the reaction, sometimes we'll get products that can go another step and also be an acid. So if you had sodium bisulfate, for example, this compound here, that can also undergo hydrolysis because it could give up hydrogen. But in this case, we were left over with sulfate, so it does this reaction. Let's write some dissociation equations. Let's do KCN, Al2, SO4, 3, Na, MnO4, NH4, ClO2.
That's what it means?
Do you want to choose your own groups, or should I assign them?
Assign them.
Assign them? Hands up for choose your own. Hands up for assign.
It's better if you sign them.
Okay, it's going to be choose your own. Get into groups of 1, get a pen, and start writing these on the board. Get into groups of 1, because I want to see everybody write. Yeah.
Can we just do it by ourselves here?
No, I want to see them, so I want to look around.
Oh, Sabine, let's do it one by one, side by side. Wait, is this right?
Ow.
I'm not listening to it.
It's so good.
Okay.
Stop. Oh, what's up?
Wait.
Stop.
So we're doing salts and water.
Hydrolysis step 2.
Okay.
So where's my right?
No, not the hydrolysis. Just the dissociation equation. If you need to push desks aside, go for it.
Is this all of them?
And I am going to be looking for your charges and balancing.
K is +1.
Taylor, you have to do it. It's in groups of 1.
You said
No, I said groups of 1.
you said groups of 2.
No.
Bro.
Notice everybody else is writing.
Oh, I don't have a marker.
Oh, go grab them. They're over there. Here's one. No, I can't throw it because I tell enough people not to throw things across the logic.
Just do it. Nike slogan. Come on.
Also, assume all of these are soluble, so you can write one-way arrows. Especially the first one is soluble. So I will do the first one.
Do you have any like not? Wait,
Oh, don't use the green one. Good job.
that's dead too.
Come here. Come here.
Do you have any like not dead ones?
Yes, I have a whole bunch up here. Let's go. Try.
Oh.
You saying I need another pack? I'm not buying another pack.
Yeah, you might.
That one is okay.
We should buy some like colored mine.
No.
Oh.
Not because I wouldn't mind colored ones. I like colored ones, but they stain the board if they stay
Oh,
on.
I see. Yeah.
And so for students writing, unless we're doing a specific thing, the black is better.
Okay. Yeah, that's fair.
No color.
Agreed.
Saves the board. Rainbow.
Red in particular is really bad on whiteboards.
Don't buy red.
I would like a big pack of rainbow, but only I'm allowed to use
No.
it. Only me. The rainbow must be under lock and key. Only I'm allowed to have it.
Like if there's no charges.
Hmm.
Duke, is this right?
Alright.
My fault.
Let's go there, right? We did it. I looked at it individually.
No, cut in the right spots. I'm waiting for someone to like cut it and write NAMN plus 04 or
So is
something.
this
So,
right?
so you look good. And make sure they didn't forget the charges. You have not. And your charges are all good. Oh, that's all I want to do. You should get some really cheap candy and just throw it.
Easy car.
I did that when I was learning how to be a teacher, teacher training, and my staff sponsor got really mad at me. The sniffer, you know, I just buy, give them a chocolate bar every day.
That would be nice.
Yeah, but eventually,
Increase my rental.
it turns out that intermittent reinforcement works better than reinforcement.
Like,
Who works-
once a week?
If you have a parent
I'll take it twice a week.
who tells you every day how smart, beautiful, and wise you are, and you're doing such a good job, and you're a parent who once in a while goes, oh, you did really well, I'm proud of you, and that happens like twice a year. Who do you work harder for? Which one means more?
Use that energy.
Excellent. Yeah, they're looking good.
Which
They're looking good. Everybody seems to be done up to at least number 4. You've got your charges. CLO2 is -1. Yep, sorry, my glasses. I still have to double check. Oh, you have brackets around something.
No, it's not.
Why is brackets around SO4?
No, but it's always.
Always
Is that why are the brackets here?
Because that's
I waited.
they're getting out of class.
You don't need it in the same way you don't need it around everything else. It's a habit I know some students develop because we're working with them, especially in your grades, they get in the habit, but you don't need it. Take them out, because then you'll get tempted to put a number beside it. But other than that, it looks good.
I'm gonna go.
Your only excuse, where are you going? I had a bunch of students leave last block for rugby in grade 10. Does that seem reasonable? Or were they,
The juniors did it.
the juniors did? Okay. They weren't just fooling me and now is the time they're supposed to leave? Remember, you're only,
I'm not so bad that I have to play for the juniors.
good luck. You're only excused if you win.
Nick, not.
Yeah.
No, that's just one because he threw it from my back. Think about it. So I'm pretty sure I hit my back first. I don't think you guys hit my back. Bro. You know me. Yeah, shut up.
Okay, looking around, I think everybody got the same one. So these are dissociation. What I was really looking for, just as a little warm-up, is because you have to know where to cut. So you cut there, but sometimes students cut there because they don't recognize the polyatomic. It's really helpful if you recognize them. Look in your table of polyatomics if you don't know, don't guess. Also, what is the formula of this if you were to say it out loud?
Ammonia.
No. Just starting here.
Oh.
What elements are these? Chlorine and oxide. I've noticed, and it's weird because this chlorine. I have heard in the last couple of years, grade 12s, 11s, and 10s, all calling this carbon iodide at times. Just make sure iodides would have capitals on them, but some fonts are hard to tell. it's far more likely to be a Cl. And if that is a mistake you make, just make sure you're familiar enough with the polyatomics that you double check, because there's very few polyatomics that are carbon iodide. Okay, let's do. Oh, there's a question. Which of the following equations? Why do we even have that lever? That's way too easy. Go. Look at why is it that time? Just close it. Put it on the side. No, just put it on the side. It can charge. Just closed. No, closed. Because you've got your notes there. Yeah. Okay, A, B, or C, or D. I'll do a poll.
Wait, how do you do a poll? Oh, it's this one.
Whoa.
You need the game show to like fully. It's giving Pablo Carter.
No, this will take too long.
No.
Take too long. By the time I put it in, I'll do it for next time. Hands up for A. One. Hands up for B.
Which one?
1, 2, 3, 4, 5, 6, 7, 8.
And me.
No, you're too slow. Hands up for C.
D for Dylan.
Hands up for D.
You're literally so wrong.
Wait. Oh, I don't even know what we're guessing right
I
now.
don't know if I take that.
I don't even know what the question is.
It's right here.
Okay, I didn't even read the
Well, this has brackets.
girl.
Never include brackets. You balance. Number 1, the 3 is part of it. You can't This isn't math. This is chemistry. You can't multiply into elements in that way. That's still NO3, so we don't want this one. This is properly separated, balanced, and has all the things. So those of you, the vast majority who voted B, are correct. Okay, next one. Dissociate and then hydrolysis. What are the ones that I liked for this one? Oh, yes. X2Y3. Dissociate these. X2Y3. And then CaXO4. Dylan, do you need to move over one?
No, we're good.
No, I'm going to make it different. Oh, I'm going to write it almost the same. It's going to be CA3XO4 because it makes it a little tricky. A little extra tricky.
That was me and Sophia. We're harmonizing.
Dylan, maybe move up one.
What's x squared? No, x space 2.
Felix, what's for lunch?
Nick? No.
I'm not on my computer.
Oh, close laptop, put it over.
Yeah.
Also, Nick, don't be a tattletale.
High green curry.
Okay, first one.
What does that sound?
Luca. What would that separate into?
Is that CA?
That is CA.
It'd be, can I answer for her?
No.
Yeah.
No, people can help Luca, but you can't answer for Luca. That doesn't give Luca any answer. Luca, what's the first element? X. X. How many of them do you have? How many of them do you have? Two. So you balance it. Plus 3y. Now, given that it's 2, 3, what is the most likely charges they would have?
Plus 3.
What is Luca?
2 would be plus 3 and y would be minus 2.
There you go. Anybody need more time on this one?
Is that CA?
That's CA3.
Let's see what the computer says.
No. The computer does terrible chemical formula.
Oh,
That was a point for Luca.
go Luca.
An A.
3Ca2 plus.
3, CA, 2 plus. Fantastic start. Go away, Creative Cloud.
XO4 minus.
XO4
Minus.
minus?
6.
Minus 6. Anybody get minus 3 out of that?
No.
Oh,
Good. Okay. Yes? What did you get? If there was I just was waiting for an error because there was some in the other class. If you know there are 3 of these, and they're each plus 2, then this side must be plus 6. There is only one of these. There's 3 there, but only 1 there. If there's only one of these, then it must be minus 6 to compensate. You will get compounds you don't know, but you will also have them matched with compounds you do know, so you're always able to work out the charge.
What's that? Is that 1 or?
Yeah, just to show that it was a 1. So I put in the balancing. Write the hydrolysis equation for the following. I'll do the first one in a moment after I write them all up, but you can just get started. NO2 minus. COO minus 2. C2O4 minus 2. Sophia, are you okay? NA?
I was just fucking. What did he do?
I don't know. He had a huge grin on it. I find it very suspicious. As my not my high school, as my chemistry 11 teacher said, I find it very suspicious when people are having a good time in my class.
Why?
We're just happy people.
Wait, so we go.
So first one I'll do. This is a hydrolysis. So hydro, add water,
Oh.
right? And then what would that make it?
HNO2 plus OH minus.
Excellent. Keep
What
going.
even is this? What's the importance of this?
Dylan? Maybe I'll move you
You
again.
should move him outside.
Outside.
Yeah, just get him outside.
Get him out of here.
Put yourself where you think your best spot would be.
I feel like
It's
it's
just
just
an open chair over here.
No, do not come close.
I'm like
All right, please do not talk to Dylan. Dylan is in the cone of silence.
Yeah, do that thing that they did in elementary school where whenever you take a test, they like set up little folders around you, like a little barrier. Folder barrier.
The next after the cone of silence will be the cone of shame.
And then what?
I do not like the cone of shame.
The coat of shame.
Cone.
In the corner.
From they always get only
In the noise.
If I got a giant cone so that you wrapped it around your neck and then it just went like this, and then you couldn't see anywhere else?
So I just have to look at
So a dog coat.
Yeah. Oh no! I'd make it human sized.
So a large dog coat.
No. It is only a dog cone if I've ever put it on a dog.
So if you go buy it from Bosley's, you could probably-
Bosley's has lots of interesting things you can apply to all sorts of grounds.
You could get one of those big ones that's actually just a donut.
No, I want the one that extends.
Oh.
Okay, write the rest of those, and once again, get into groups of 1.
Oh, I already did that.
What? I did it all.
Hold on.
Let's do that.
You work very fast.
I understand this better than I watched this all wrong.
Nope. Oh, the last 2.
Okay.
You fell into my trap for the last 2.
Oh, is it?
Well, for this one, you definitely fell into the trap. For this one, you have to make a decision.
What are you talking about?
I will make a little line here so that everybody knows there's a trap at that point. Write them on the board.
If you could track
Go. Write them on the board. Go. Write them on the board. Nick, go write them on the board. Eric, go write them on the board.
Is this what we're doing?
Use your hands.
You're good.
H S 4 minus and then it would be an eight.
Wait, I did it on my phone.
You're good.
What? Did we just finish this last?
Do we just do the last two?
Eric, though, it's like,
I'd like to see them.
don't be a slave.
No, just help me.
You're a slave.
Which one was the chick? Lost. Oh.
I'm gonna add one
I fixed the HF.
because to be honest, as a class, you're doing too well. Too well. Hold it. Let me make sure that one works. Where is HCO3? Make sure that's a good example. I think pretty much everybody started off doing these, as far as I know, well. So I'm going to start with these.
Good.
Is it this? That's not different else.
Yep.
Earlier when you asked
I added an extra one.
No,
But is magic trick this? Is it that it
Yep.
actually does that?
Yep. But then the last one, you have to make a choice.
I choose
This is not
Well, there's two choices. One is correct. One is incorrect. Both are possible.
such a weak base.
Never choose. Meth and medication for life.
what?
Medication for
Some meth and medication for
There is rumors, substantiated rumors, that there is a derivative. We don't know what chemical it's based on, but people are actively trying to find out because apparently they have access to this. In the military, if you're a pilot and you need to stay up because you're flying a large piece of expensive equipment for longer than 24 hours, that you can stay awake for up to a week on this.
Because
You
of
just keep
math?
taking it, you're alert and competent at the same time,
And you get
and
sick?
apparently not addictive.
Is it bad for you?
naturopathic.
Did you say it's coke? Is that modafinil?
Mr. Newval.
No, this is like a drug
No,
they
but like
apparently.
remember you were talking about that?
Oh,
Like,
yeah,
on
yeah.
Nature's Birth, yeah, I figured out what one I used to be given as a kid. It has something very close to meth.
Oh,
Yeah.
lovely.
So we're just
Yes.
Well, there's the other one that they use.
Did you see that laser? There's a laser.
What's the
It's like
I'm delusional.
Oh, yeah. I've read those stories. Felix,
Is that medication bad for your body?
we don't know about it. They claim it's not. But also, remember, meth was invented to keep soldiers awake. Like that's its purpose.
Come here.
I thought all the dreams were
It was this one.
And it turned
I
out.
know, because it was banned right before COVID, and during COVID, my dad had lunch home from the store, as he just did, and then he gave it to us. So he gave it to us after it got banned, and
Oh yeah.
it had toxins
Yeah.
very close to
There is a new herbal. I should maybe bring it because it's chemistry related. There's a new one that if you take it, it is so bad for your liver, and it's in a ton of products now that you're supposed to avoid.
I know it's
Anyway, I want to get back to here because we have lots to do. And everybody's done. Looking this way. I want to go over because the last three are particularly important. The first ones are just to practice. Do you know how to write the equation? Chloe? James? Dylan, what are you doing back there?
Oh, sorry.
Now, as far as I can tell, looking around, most people did the HF correctly. So we have this one. And what are its two products?
F minus.
F minus
And
plus
H0
H-Rail plus. There was only one possible reaction for this one. Why?
Because it goes in one way. It's very strong.
It's very strong. H2SO4 goes a one-way reaction to SO4 minus Eshma, Luca, plus H plus. If this is a one-way reaction, then that means from HSO4 minus, you can never get H2SO4 as a product. That cannot happen. So this only has one product. This can only be an acid.
Wait, so it can only go that way?
This can only be a proton donor.
So
Dylan,
it can only go this way?
well, you're just pointing directions.
Like
You-
the arrow, like, I mean, don't you have to write the arrow one way, or?
No, you can write it both ways. This isn't a strong acid. It's a weak acid. Eshwan? It's a weak acid. You react it with water. It gives off. It has a Ka. But it cannot act as a base to make H2SO4 because H2SO4 is a strong acid and immediately it goes to HSO4. So it can never be a proton acceptor because then you make H2SO4, which is one-way arrow the other way. This is in contrast to HCO3 minus. This is amphiprotic. It's got a hydrogen, so it can give off a hydrogen. It also has a negative charge. It could accept a hydrogen. So which way could it go? Now, you could write either one. They're correct that they both could happen, but one is far more likely. If you go to your table, is it a stronger acid or a stronger base?
Acid.
We go down and we look at it all the way here.
That's what I don't know.
Here's HCO3, and here is HCO3. Is it a stronger base or a stronger acid?
Stronger base.
Stronger base. So it's higher up on the base. It's 4.3 times 10 to the minus 7 or 5.6 times 10 to the minus 11. We would still have to do the calculation with that to get the KB. But 10 to the minus 14 divided by 10 to the minus 7, to do it roughly, is going to give you 10 to the minus 7. That's going to be a lot bigger than 10 to the minus 11. So, but even just comparing roughly on the scale, we can see, oh, it's a much stronger base. It's about a middling weak base. So,
Wait, I have a question. You know, for that HSO4, what have you put H?
no, I'm done this part. Where is the thing? There it is. So if we go all the way back, we know it's a slightly stronger base. So if you have to make a choice, then you say it's more likely to be a proton acceptor than a proton donor. Dylan, question.
You know how you look for the HSO4 one? You wrote H3O plus first. Are you able to write are you able to write SO4 negative or 2 negative first?
Yes.
Because that's what I did.
A plus B
Oh,
is
it's
equal to B plus A.
Okay.
They're identical. We are not doing the type of there actually is a version of math that is not true, but it's not in the regular versions of math.
Okay.
Some versions of math. 9 plus 6 is 3. Yes.
Do we have to indicate the amphiprotic one somewhere that its base that is stronger when it's a base than acid?
You will get questions eventually that are things like, what is the most likely reaction for this compound?
Oh.
And then you have to look it up and make a choice. So you have to recognize that it's amphiprotic and then pick the right one.
So that means this unit will also be looking at the table. For
Yeah, that is a specific learning outcome. I don't know exactly which one it is, but it will come up and then we'll be doing it. I'm doing it now because it all sort of comes together with hydrolysis. We have a sodium nitrite solution. Write out the first. Write out the dissociation, and then the correct hydrolysis. And where are we on here? That's not what I want.
That is so wide.
So dissociation can almost be done in your head. You want to correctly divide it in half. Sodium is soluble with everything, so it's a solubility equation. Sophia, what two ions do you get?
Na plus NO2 minus.
Excellent. Which one of those is going to react?
NO2
Oh, 2 minus. How do you know that?
Because Na plus is not gonna do anything in water. It's
Yeah. And you can find this on your table. It's a base. If you look for this, you won't find it. There are a few things that aren't on your table. However, what I find helpful is that Na plus comes from NaOH, which is a strong base. And we know the conjugates of strong bases and acids don't do anything unless they can do something completely else. This can't. If this is a strong base, this can't act as an acid. So all of the +1, +2 metals don't do anything. They're all spectator ions. You remember spectator ions? They're the things you need in order for the thing to happen, but they're completely useless and don't do anything.
Wait, Mr. Newville.
They're like bards. They think they're the post member of the party, but they don't actually do anything. Yeah.
What's the difference between spectator ions and like catalyst? Is it just catalyst that speeds up the process?
Well, what's the difference? Catalyst actually provides a different mechanism for the reaction. Spectator ions don't do anything.
But but can you say that catalyst is a type of spectator ion, but not every spectator ion is a catalyst?
I don't think our definitions include a catalyst as a spectator ion. A spectator ion is defined as something that doesn't take part in the reaction. It may be present on both sides. So superficially, you might think, oh, that's a catalyst, but it doesn't provide a different mechanism. The reaction doesn't go faster because it's there. It's just there. It could be any spectator ion. This could be sodium nitrite, it could be potassium nitrate, it could be lithium nitrate, it doesn't matter.
Also, is mass invented or discovered?
You already know. We've said this before. 2 + 2 = 5 for very large values of 2. Okay, write the hydrolysis below that.
Would it just be NO2 minus?
No, say it aloud, let people give them a chance.
Oh, Mr. Newville.
Am I going to regret letting you ask this question?
No,
Is it about math?
it's about the stuff on the screen.
Oh, yeah, okay.
What does the pull button do on the right?
The pull button?
Yeah,
Right.
On the
Oh, if I pull it, it provides me with the answer.
Oh.
Whoa. Are we supposed to write the states?
Yeah, you have to write down the hydrolysis.
No, like the states, like aqueous and like.
Oh, yeah, you should. It's a good habit not to fall out of. And then, once you've done that, do it for the second example. Sophia, can you put your laptop away? Why is it? I've said enough things about laptops.
Oh no.
Ooh, Waterloo Engineering. Look at it.
Mr. Newville, how do you add like gadgets like these, like the pull buttons? Or is it just an image?
It's just an image, and then you attach it. You can group things,
Oh.
and then you just can do that. And they have pre-made images for some effects.
Mm.
The reason, I mean, I think other than Mr. Snow, I think we're the only two that use this software now.
Well, Mr. Snow doesn't use all these gadgets,
I think Mr. Snow thinks gadgets are silly.
but that makes the class like more interactive, you know.
I could even put sound effects.
Do it! Still have a board.
We should have more of them.
Okay, for this one, you don't have to write the dissociation. Just determine the spectator ion and write out the correct hydrolysis. So, get rid of the spectator ion, write out the correct hydrolysis.
How do we know which one's the spectator ion?
How do we know which one's the spectator ion?
I feel like it's
NH4 doesn't
cooling.
show up, does it?
So, spectator ions are all of your +1 and +2 metals,
So chlorine. No, chlorine, yeah.
and all of your conjugates of strong bases.
Oh.
Oh, sorry, conjugates of strong acids. Oh, right, you told me the thing. Yeah.
Wait, so
Good luck.
CL would be this spectator.
So, Cl would be the spectator. Why is HSO4 not a spectator?
Because it, I don't know.
Dylan?
Yeah.
Luke, if you're going. Get outside. Outside of Why is HSO4 not included as a spectator?
No, because HSO4 cannot act as a base.
It cannot act as a base, but it's also not a spectator.
It can still do something.
It can still do something. We can still find HSO4 right here.
Oh,
So although it can't act as a base, it can act as an acid. So all of your spectator ions are these and metals +1 and +2.
Wait, why didn't like the table include like a list of amphiprotic ions? Wouldn't it be like easier for us to access those?
But it does show you a list of amphiprotic ions.
No, like where they like maybe highlighted.
Oh, like
Because they don't
like spoon fed?
Yeah.
Yeah, because it's spoon fed. Because with this one table, you can get all the spectator ions if you want. There's HSO3. There's HSO3. It's on both sides.
But where's NH4?
Plus.
Yeah.
So it's NH4 plus
Isn't on
is not amphiprotic. Is that what you were asking about? There it is.
Oh.
So, and is this an exhaustive list? No, but these are the ones you need to know. The ones that aren't on here are the ones we use for questions when we want you to calculate the Ka.
Wait,
So we deliberately don't put everything on there.
Mr. Nicholas, so this equation doesn't have any spectator ions because there's no +1s or +2s.
And what else are spectator ions?
Oh, the those things.
Yeah.
The special.
Hold it. I'm not gonna write spectator. I'm gonna do
The
this.
strong bases. No. What?
What?
Those are weak bases. No, those are strong
They're
acids.
not bases
They're
at all.
acids.
They're specters.
Okay.
Specters.
Are they good? Oh.
Please do not play with the pet. With the specter. Okay, I'm assuming everybody has it then by now. Pauline? Spectator Cl as a product of HCl. So our spectator is chlorine. We are left with NH4 plus. That reacting with water gives us NH3 plus H2O. So now we can start to define things.
What?
Eric?
No, don't take it. No, I need my highlighters though.
Wait, can I get one for please?
You what?
Can I get one more for
No.
Sit down.
Nope. They are all mine.
It's actually like strong.
All mine.
Early today. done so much.
We're so tired.
We've actually gotten through so much.
We've done a lot.
We
We're
have.
still not caught up with the other class.
Where's the process?
Where's more money?
No, we need to speed up.
No.
Yeah, no, we need to move.
Where's the other process?
Um,
Tell us what the
a
other
reminder, your final exam will be very thorough. Anything not covered in class will be covered on the final exam.
Oh.
So it's not so much where they are, it's that we have to be at a certain point at a certain time. And I'm taking advantage of every moment of class time we can to make sure we get there,
Yeah, I mean,
because I think it would be nice if we had some review days. I'm not sure we will,
What?
so we
How much-
need
so
to
much to
keep
cover.
moving. Okay. I would like you, Sophia. What's your favorite strong acid?
HCl.
No, it's not Sophia.
H2SO4.
Nope, anyone but that one. You said HNO3 first. I'm going with that.
No, I didn't.
Yeah, you did. Dylan, favorite base?
Favorite base?
Strong base.
I don't have my sheet with me.
Strong base. It's not on your sheet.
NH3.
Nope, that's weak.
OH.
And it what?
OH.
You gotta put it. You gotta put it with something.
NOH2.
NH2.
N what?
NaOH.
Thank you. NaOH.
Jesus Christ.
Oh, that's a
Favorite weak acid.
That was a secret.
That is strong.
What?
H2O2.
HSO4.
H2O2.
H2O2 will work.
Oh wait. Could we do H2O?
We could, but I don't want to because that would be a hydrolysis, and we're doing some non-hydrolysis equations. So we got H2O2. What is a strong base?
Strong base?
Yeah.
NaOH.
Sure.
Well, KO.
We can change things up. Okay, we'll make it a KOH. Excellent. Give me another strong acid that isn't H2SO4.
hydrochloric.
Hydrochloric.
That's the same thing.
No. And now I need a weak base.
IO3.
IO3. IO3. Hold it. IO3 is there. Ooh. Yeah. So, now it can't just be IO3 minus. You need to put it with something.
HIL3.
No, then you have an acid. That's not a base. So put it with something that isn't H.
Li.
Lithium. Li. IO3. So lithium iodate.
Okay.
Now, predict the reactions.
Blood.
There's so many more. Gesundheit.
Wait, but that becomes NaH2O. How does that?
NaH2O? What are you talking about?
NaOH2. Never mind.
There we go. NaOH2. What?
Because if it's acid, it'll give it away, right?
Bro,
For
acid
HNO3.
plus base
What are we
is
doing?
water.
Oh, I see.
Oh my goodness.
Hydrolysis.
I'm stupid.
I think, how many people? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Maybe if I put you in pairs again.
No.
No.
You move fast, Mr. Phil.
Can we choose our own pairs?
Yeah,
Like
we're
big
behind
We
ones?
move fast. We're behind. We gotta go. We gotta just
We
do
gotta
that
keep
shit.
moving, Mr. Newcomb.
We don't have to use cells.
I dislike it when people start using my own arguments against me.
Well,
Okay, then what's the products of this?
NaNO3 plus H2O.
Is there anybody who needs more time on this one? It looks like they do, so I'm going to stop now. Hmm.
Mr. Newfeld.
Nice to meet you, Confused. I'm Mr. Neufeld.
For that.
Mr. Newfeld.
Nope.
I don't.
What if it's neutral molecular?
What if what is neutral in this reaction?
Second.
The second one?
Yeah.
Oh yeah, it is. It just like
Because
produces
what are you
this.
gonna make another KOH?
Did someone not find that on the acid base table?
Does it not just make the exact same thing that it was before?
Who gave me H2O2? Yeah, no, it's on there. It can act as a weak acid. It's a very weak acid, but it's a weak acid. It's on your table.
Would it just be
It's near the bottom on the left.
H2O plus KHO2?
It's going to give off HO2. It's going to give off a hydrogen because it's acting as an acid.
HO2.
Yeah, that,
That means it'll be KOH2.
KHO2.
Shit.
Yeah. No, you said H2. So then you went OH2. And
Like
then,
KO2H plus H2O.
yeah, that works.
KHO2? And H2O.
W37.
No.
Yes.
HKO.
KOH2. No. KO2H.
Wait, why is it not
KO2, yeah, that's what I
K2O?
said.
With Mr. Newfound, why is it not K2O though?
Pardon?
KO2H.
I don't know. We're going to go over it in a second. I'm just waiting. Is there anybody who needs more time on the second one?
No.
Someone who has not yet offered their opinion? Predict the products for me. Put up your hand.
I can answer.
One second.
No. No, please.
Oh, it's a nice puppy, though. Cute puppy.
How are you gonna go fast?
Okay, products.
K2.
Dylan.
This is definitely wrong. KO2H plus H2O.
Bro, he just said the answer.
Is that what he said?
No.
Yeah. No,
Wait, am I right?
Isn't the
The-
H go first?
the H.
HO2.
No, that other H. Well, you could.
It doesn't matter.
Sorry, it doesn't.
It doesn't
No, it probably does. I was just looking at that. You had the right numbers of each one. So that H2. So KHO2 is probably a little better.
Okay, that makes sense.
Why,
Plus H2O. Yes.
why can't it be K2O?
Why would it be K2O?
Because the K and the O. Because like for the first one we do the Na and NO3, right?
Yep.
The cation and the anion.
I do not believe that the product, the HO2 minus is not an acid. That you can't get that last H off.
You can't.
No, it's just not coming off. It's not diprotic.
So how, can you explain how you got to KHO2?
Sure. This, I said give me a weak acid. That's a weak acid. It donated a proton to there.
Okay.
So we got H2O. And then we're left with HO2 minus plus the K. Dylan, turn your seat. Did that make sense?
Yeah.
I'm just waiting.
Yeah.
Okay, because I don't, because if the hydrogen goes over here and then the potassium goes there, because an acid-base reaction is a bit like a double replacement. So we get that as a product. And if we have HCl and LiO3, Sophia,
Lickle.
Lickle plus,
HIO3.
excellent. Now I'm going to take, let's go with, what color is they? Red. This was a strong acid and a strong base. We made water, and that's neutral. Is any of these a weak acid or a weak base or a spectator ion?
And then you spectator.
Yeah. How about NO3?
That's like
Strong.
a base.
Strong
Weak base.
acid. Wait.
Base
Weak
probably.
base.
Weak base?
Wait.
I would.
Yeah.
All of these?
Or
Yeah.
Spectators. Specters. So if you're the conjugate of a strong acid, so if you have a strong acid, its conjugate cannot react. If you have a strong base, its conjugate cannot react. So both of them spectator ions. And this whole solution, you will make a neutral solution. Provided you have a stoichiometric amount of both and they completely annihilate each other, you don't have anything left over, a solution of sodium nitrate and water will be expected to be neutral as the water was. However, again, water, neutral, don't care about that. But we had a strong base. So where is the spectator in here? Yes?
K is the spectator.
K is the spectator. So that's from here. And what about the HO2?
Never seen an HO2 before.
If this is a weak acid, what
It's a
must
weak
that be?
base.
It's a strong base.
Strong base?
Weak base.
Weak base.
Oh.
This is a weak base. It's on your table opposite H2O2. Felix?
But it's on the base. It's on
Where?
the right side on the bases, on the bottom.
No, if I get it, I put it up and you get it when you leave. Otherwise, I have to give it to your customer.
Mr. Neufeld,
Yes.
How do you like name HO2? Like hydrogen,
So then it's
dye?
I don't know the name of that particular hydrogen. That's hydrogen peroxide. So this would be a version of the peroxide, but I don't remember the name.
So it's weak, or it's basic.
So this is a basic solution.
Okay.
So if you have a weak acid and a strong base, you end up with a basic solution. Because that HO2 minus can undergo hydrolysis, react with water, create hydroxide, and so on. If you have a strong acid and a weak base, what will this solution be?
Acidic.
This will be acidic. Because our salt is spectators,
HIO3 is penalty.
and this is our conjugate weak acid. That was made from our weak base. So if you have anything that's weak in your reaction, it makes its conjugate, which will then affect the pH of the resulting solution. So you can't get a neutral solution from a weak acid or a weak base because its products are also weak acids and weak bases.
wait, Mr. Neufeld.
Yes, Eric.
So strong acid and strong bases make.
Neutral solutions.
So whichever one's stronger that's the solution that'll be, unless they're both strong, then that'll be neutral.
Right.
And then if they're both weak, it'll also be neutral.
Well, they're both weak. You're going to make two conjugates. You would compare their Kas and Kbs and see which is more predominant.
Okay.
Answer the next question.
Who's gonna?
Wait, the net ionic is without the spectator ions, right?
Mm-hmm.
Okay.
What are we supposed to do now?
Answer that question.
C, no?
Why do you put
It's
the
C, it's literally C.
Because it's Kahoots.
Are we doing the game show?
Say.
Which one did you do we think it is?
C.
C.
C. Why is it not A?
Because they don't have the C in it. And K plus is also the spectator ion.
Yeah, so we've got spectators here.
So look
Spec-
at this
That's
also.
so we don't care about
And B
those.
also the spectators.
Because
so
it's a
take that
metal,
out.
correct?
What is
This also has spectators. So
That's
it can't be the net. We have to remove all the spectators from that. This doesn't have any spectators. So we've taken KCN. We've taken out the spectator, which is K plus. CN minus plus H2O goes to HCN plus OH minus.
K plus is the spectator because it's a metal.
Sorry?
It's a metal with a charge plus 1.
Yes, it is.
That's why it's the spectator.
Yes. All your plus 1 and plus 2 numbers.
And the ones that are really strong, that don't have two, that can't act as a base acid.
Right. Yeah. From the strong acids. Yeah. Why is this one not it?
Because you give it an O?
Yeah, it was just weird. That's just weird. This person didn't look at their table and took a wild guess.
It's HSO4 no. Like, that's the only one that does not react.
That's the only one. HSO4 is the only one that will react with
Like,
water,
will react,
but
it's
it,
not, it's
it
not
does it
react.
so as an acid. For the next question, what?
Final minutes.
Mr. Newfeld, we almost caught up.
What?
Are we ahead of them yet?
Oh, we want to be ahead of them. Yeah.
Are we ahead of them?
I'm not going to tell you.
Where are
Yes.
they?
They'll change your mood.
Oh,
You're ahead of
we're
them.
not.
Let's celebrate.
Yes, we are.
Oh wait, we are. You just want us to get to like overconfident.
Celebration, yeah.
Can we
That's
do
not
this
what
question?
Sean
Go.
Let's do this question and then go. How about that?
I will say, if you show me the answer to that one, you can go. Then you have to bring it to me. Which
What
ions do
ions?
not react with water?
What are our options?
Some sort of statement, you show it to me, if it's correct, I want you to include all the major ones.
Oh.
I've been telling them to you like almost every question now, so.
Wait.
Sodium doesn't react with water. I know that.
If
Bring to me. You're missing a whole class.
What?
And put it under here, but you're missing a whole class,
What do you mean class?
like group of things. You're missing a ton of them.
What?
Yeah.
Is it this? Okay.
Yep, you're missing about half of them.
What about me?
show me the answer.
Bro, what?
You just said strong acids. They definitely react with water. And spectator ions are kind of what I'm asking you. Define them.
Yeah.
Which spectator
Oh.
ions? Yeah.
Is there metal ion plus 1 and
Oh, I'm
plus
not gonna tell you.
See, that's about half.
Yeah, you got about half of them.
is the other one?
plus 4.
Is this?
What about like
They don't know.
no gas?
Oh, those definitely react with water.
Okay, what about these?
I want ones that do not. That's half of them.
It's
Oh my
plus
god.
2 plus 1.
Anything with a plus or Wait. Meat is strong. Something stronger.
Ions of, not every.
He said the strong.
That's a good list, but one of those doesn't belong.
No.
Yep, you're good. Yes! Let's go.
Something to do with strong acids. I don't know.
No, too vague.
You got it?
Nope, you're missing half of them. Your second sentence doesn't make sense. No, that's good. Those, ooh, yep, you're good. Oh, you have one exception in there.
Sophia, help me.
Well, yeah, normal gases too, but there's another major class I'm looking for.
What's the first?
Yeah.
These are what spectator ions are.
You know what?
That's half. I need
That's
another half.
not, this is not.
No, he said I'm missing it.
Those all definitely react with water because they're all the strong acids.
This is not nice.
What am I missing?
Yep, exactly. Metal ions, plus 1, plus 2, yes.
This,
Alkali metals is another way of saying those. So you're missing still have the same half.
Oh.
you're missing before.
oh my god.
We need to get
Okay, ready? I'm gonna show you once.
and
Ions of, because it's plus 1, plus 2.
Oh, anything with a plus or 2 plus?
That means all the metals that have a plus 1 and plus 2 charge.
What are we missing?
The charges are not.
Why did you
There's
include
just
this?
one of these
That
that's
doesn't
incorrect, that's all.
Oh, but those are my
Let's get down to the yes. You're good.
Wait, but. Oh, it's in the
Got it. Take that one off. You're done. You're done.
Wait, the student
Put
is
ions
this one
on
too?
before the other ones.
Put it on the table.
Taylor, which one?
You got all those, you got all plus 2.
HSO4
You're
minus
missing half. So there's a whole group, so you've got all the positive ones, what negative ones?
Is it that and that?
Conjugate basis of strong.
Those
Oh, yes, but there's an exception. that we specify.
What am I missing from this?
Spectator ions, no ions, no bonds. and
Yeah,
noble
I'm
gases.
missing the exception.
Pardon?
Oh, this one.
Let's see. You just wrote a bunch of acids there. Those definitely
Strong
make it.
acids and conjugates of strong bases except
You wrote a bunch of acids there. All those acids. are acids.
Wait.
Oh,
Is
well, you have to write it out. I don't know what you mean by
Wait,
it.
no, guys are not.
Thank you very much. Plus 2. You're welcome.
Is it missing?
No, you're missing a bunch. Conjugates, strong acids, except H2SO4. Good, done.
then we're still on for tomorrow night for prep. Oh no. Okay.
If you have not yet gotten it, you can come see me and I'll tell you what you're missing and then you can help.
What are we missing?
You had those plus 1 and plus 2. So it's all the conjugates of strong acids.
If not,
Except for HSO4 minus, because it can act as an
all the
acid.
other ones have. Well, here's the thing I have to do is I have someone that comes
That's what I meant.
Great. Thanks for the long lunch line, Mr.
You're welcome. I'll be there in a second too.
I probably.
Conjugate of what?
Okay, cool.
So you have to say
strong acids.
conjugate of strong acids except HSO4 minus, and then you're good. Yeah, you're good.
Because
I wrote that down.
Whether or not we have constant for it.
Okay.
Because I just I just need to
My
see
turn.
on lunch how to get
Okay.
what
You,
your
come on.
Also,
diet
no
is.
Plus 1
But I don't
conjugate
know what I
except
can do
HSO4.
for
Yep.
understanding that.
No gases are
So
not.
once I get that, like,
No.
we're good, we are good. and I
They don't
can-
react to anything.
Yeah, I don't.
So it's one of those statements that's technically true, but not
It's
really.
okay.
But it's
That's
not
why we're
ions.
gonna sit-
But it's not a.
If we don't. Yeah.
What is for lunch today?
Absolutely, that's the thing. I actually
Oh,
have, like,
I like that.
show that one, and then once I understand what our diagram is, I can keep working on it. I also, it also.
Thanks, Drew.
Go on. Thank you.